So now that we understand the square root property, we want to learn a set of steps to help us convert these quadratic equations into the form where we can then utilize that square root property. So our ax squared plus bx plus c's, specifically ones that don't factor, is where this process is very useful. We can use it on any form of this equation of this form though. So let's take a look at the steps because they kind of bounce around a little bit. You have to make sure you know what you're doing and why you're doing it. So first and foremost, very important, for an ax squared plus bx plus c equals 0 equation, we do need to make sure that a is a 1. So we'll see what happens when that's not the case, but we have that for this first example. So here's our equation. Now the next step is just a setup step. It says move the constant c to the other side. So my next line, however, what you want to make sure you do is when you move this, in this case, negative 32 on over, leave a space where that used to occupy. There's a reason for that. Now, the next step is the side work. So it says take 1/2 of b, square it, and then add that number to both sides. So what I do to organize that work is I call this the magic box part of the problem, or the magic box step. So you take that value of b, whatever is your coefficient on this x term here, and you take half of it, and you square it. So off to the side, I'll just say that b here is a -4, half of -4 is -2, squaring -2 is +4. That's just kind of how I organize my work to get to that point. Because we have to do those very specific things to then take that number, if you want to call it the magic number from the magic box, that number gets added to both sides. To both sides, because obviously we want to keep this thing balanced. We don't want to change the equation. So putting that +4 in the blank we left when we moved the constant, but then balancing the equation with that +4 on the other side. Now, what we've done, again with that very specific set of steps, is we've created this trinomial that factors. Now, step 4 says factor the left side. It will always be the result of a square of a binomial. That's what this has allowed us. It will give us a trinomial that will factor down, and I'll write it this way this first time, numbers that multiply to +4 but add a -4 are -2 and -2. And that will always happen to where we will write it like that. We will be able to write it as the binomial squared. That trinomial will always factor to a perfect square binomial. And then the right side will be whatever you get when you combine those two numbers. And notice now we have the form that we were working with previously in this section. Something squared equal to a number. So that amount of the process there, the making sure lead coefficient's 1, moving the constant, magic box, and factoring and combining, all of that gets us to the point where we can then say this is something squared equals a number. Let's use our square root property. Square root of the left side equals square root of the right side. Square root of the square leaves us with what's inside. Don't forget our plus or minus here. And then the square root of 36 is just 6. And so, move the 2 plus or minus 6. Now this is one of those plus or minuses where you don't need to write them separately with the plus and the minus, because you can actually do 2 plus 6 and 2 minus 6. 2 plus 6 is 8. 2 minus 6 is -4. Now, something to point out here, just because this is good to understand, we got really nice numbers here, right? Integer or rational values, especially the rational values here. Nothing involving square roots that we couldn't simplify. That tells you something. That tells you that we could have gotten those answers from factoring. And so if you notice, I didn't point out or didn't attempt to factor this in the beginning because it actually does factor. If I ran across this thing on any quiz or test, I would always say, check factoring first, because it's a lot faster and simpler than this process here. But we're designing this process to help us with ones that we can't factor. But it's good to see that it does work on ones that do factor as well. It's just more work to get to those final answers of 8 and -4. Take a look at a couple more. All right, so we have everything on one side. We have a 1 out front. That's all great. So we will start with the moving of the constant. So I'll add the 1 on over. Now, to fill in this gap here, we will make our magic box. Start with the value on the x term, 2. We need half of that. We need to square it. That's it. That is your magic box right there. That is your magic number. Oop, I'm running out of ink. I guess we're switching to blue. So with that 1, we take that 1 and we add it to both sides. Again, that magic number is going to go right there. Now, with that magic number added to both sides, we can take this trinomial and we can factor it. Specifically, it should always factor to a binomial squared. 1 times 1 is 1, 1 plus 1 is 2, so that is going to be both a 1 and a 1 for our number game. And then over here, 1 plus 1 gives me 2. Now we are to the form of the square root property. We got something squared equals a number, so we can take the square root of both sides, giving me just plus x plus 1 there, and a plus or minus the square root of 2 there. Right, we can't simplify that at all. So then we move the 1 over as a negative. So we have negative 1 plus or minus the square root of 2. So our solutions here are negative 1 plus root 2 and negative 1 minus root 2. All right, for the next one, let's go ahead and get that equals 0 first. That's very important. Oops. If I can write it correctly. Now, the reason I want to do that and get them all to one side is because this a is not a 1 yet. We need it to be a 1. So we're going to go ahead and you could think of it as factoring out, but actually to get rid of it and make this more convenient, we're just going to say divide everything by 2, right? Divide both sides by 2, or even think of it as divide every single term by 2. We can divide it out, giving me x squared minus 4x plus 2 equals 0. Now, from there, we recognize this as the form we're going to use to complete the square on, so I will move that 2 back across. Technically, you did not have to move it here, move it back. You could have just divided everything by 2 immediately. I do like to usually see the form of everything equals 0 and work from there, but it's not a requirement. So we get to that form. Now our x squared has a 1 in front of it. Now we can go over to our magic box. So in this case, we're going to use the b that's now here of negative 4. Half of that is negative 2. Squared is a positive 4. And so positive 4 will be the number that we add to both sides. On the left, creating the trinomial that factors into x minus 2 times x minus 2, so x minus 2 squared, and over here getting a positive 2, and then jumping into the square root property, which leaves us just x minus 2 on that side and plus or minus root 2 on the other. And then I'll just add the 2 over to the other side and get 2 plus or minus root 2. So my two solutions are 2 root 2, 2 plus root 2, and 2 minus root 2. All right, let's take a look at this next one here. X squared x no x, 1 in front, doesn't factor, so we'll move that 17 on over. Now we'll go with the magic box. This magic box, our b is 6, half of that is 3, and squared is 9. There's the 9 that we're going to add to both sides. Once we've added that to both sides, the left-hand side is going to factor to x plus 3 squared. And the right-hand side, we can combine those and get a negative 8 for a result. And now we can use the square root property. Square root property gives me just x plus 3 over here, and plus or minus the square root of negative 8 over here. Now, let's look at that. Let's look at the square root of negative 8, because there's two things to do. First of all, square root of a negative we know is going to result in an I on the outside, and also an 8 can be reduced, can be simplified. So 8 is 2 times 2 times 2, so a pair of 2's can come out as well. So the I is coming out and a 2 is coming out. So I'll have x plus 3 equals plus or minus, and this can actually simplify to a 2 and an I, and then that last 2 remaining on the inside. So again, that 2 came out, the negative came out as an I, that 2 left over inside. Now I'll subtract a 3 on over and get negative 3 plus or minus 2i root 2. So I can write my final answers as negative 3 plus 2i root 2 and negative 3 minus 2i root 2. So with this process, it's my intention to not make this process be something really difficult and ugly, computationally speaking. So there's two situations where this process can definitely get more involved. It's not that you can't do it, it's just that you would have to work with fractions, which can be sometimes inconvenient or annoying. I want to show you the two situations that would arise where I want you to understand that this would not be the approach that I would want you to use. Again, not saying you shouldn't be able to, I'm just saying I won't require you to work with the complete the square process if one of these two things were to happen. So if they do happen, you know something else is needed. So for this first one, if I were to subtract that 3 on over to get equal 0, if you were to approach this with complete the square, although it does actually factor, if you were to approach with complete the square, you would need to get rid of that 4. Well, as you go to divide everything by 4, notice fractions, right? Or even if just one of them is a fraction, that would be a situation where I'm going to tell you we're going to learn another method in the next section that I want you to use that method instead of dealing with the complete square process with all these fractions involved. Now over here, notice that's already a 1, so we're good to go, it looks like. So I can go ahead and move the 4 over and then work on the magic box. Now, for the magic box, b is this 3, and half of b is 3 halves, right? There's a fraction as well. So if you encounter fractions in the process, know that this process of complete the square is not what I need you to be able to do to solve this problem. There'll be a different method that we're going to look at here in A2. Again, not that it can't be done, just I'm not going to require you to do so.